Okay, so लास्ट लेक्चर में हमने डिस्कस किया था रेशियो कंट्रोल्स को और we discussed that ratio control is a kind of feed forward control और ये feedback control से थोड़ा सा different है. And here we develop we presented actually two methods. Method one for the ratio control, this is method number two, and then we compare it with this in the green color block diagram of the feedback control system. Further हमने स्टडी किया कि एंड देन वी फिगर आउट के जो रेशियो कंट्रोल है, इस रेशियो कंट्रोल के अंदर वी नीड टू मेजर एक्चुअली टू things, जिसमें disturbance is one important variable and the manipulated variable is the other one. Okay, so in feed forward control, in the red line, this red line is mentioning the feed forward control, and ultimately control objective is same, but to achieve this control objective कि आपके पास जो आउटपुट है वो अपने सेट पॉइंट के ऊपर ही रहे, इसको अचीव करने के जो मेथड्स हैं, इट कैन बी अ फीडबैक कंट्रोल, इट कैन बी अ फीड फॉरवर्ड कंट्रोल अकॉर्डिंग टू द एप्लीकेशन. हम either of these two या a combination of these can be we can use. Okay, so in 15.1 from the book, ये पिक्चर है जो शो कर रही है हमारे पास के feed forward control में we don't have any feedback from the output. Okay, no feedback here, but we have a feedback signal from the disturbance. और ये जो सिग्नल है ये हमारे कंट्रोलर में आएगा. दिस इज अ कंट्रोलर, फीड फॉरवर्ड कंट्रोलर. इसको नाम हम फीड फॉरवर्ड कंट्रोल कर देंगे. एंड देन वी हैव दिस न्यू स्ट्रक्चर. So this is called feed forward control. Feedback control में we will have no idea about the disturbance from the controller perspective, or we will be having a feedback from the output. Okay, but there are some issues. So against those issues, I put a question here. कि feed forward control में measurement हमारे पास disturbance है, measurement हमारे पास uncontrolled signal is U. फीडबैक में मेजरमेंट y है और कंट्रोल सिग्नल u है. सो दिस इज अ क्वेश्चन हियर कि why the feed forward will perform better in rejecting or dealing with the disturbance as compared to the feedback control. It's logical कि हम पहले कोई MATLAB में या LabVIEW में इसकी सिमुलेशन भी करें, but right now what I want is to have the answer for this question, and I will reserve like bonus marks for it in this session. ठीक है, सेशनल मार्क्स के लिए फिर मैं इसके लिए बोनस मार्क्स रखूंगा. आप now try to attempt to answer this one. जी, who would like to answer this question? Ali Irtaza.
Now look at me, I'm a fucking scarecrow and I'm running away from a guy dressed as a bat. I should have just specialized in dance like I wanted to. Oh, this looks good. Oh, Batman never goes in alleyways. That's enough. You're going to jail. Well, guess who's gonna visit me in jail, Batman?
No one has the answer, so you lose an option for the bonus. So let me continue from here. Gee, anyone, if you want to attempt this option for your marks, please tell me. I'm waiting.
सर फीडबैक के अंदर ये होता है कि ऑलरेडी डिस्टरबेंस हो चुकी होती है, मतलब आउटपुट में चेंज आ जाता है तो हमें मतलब नुकसान हो जाता है, लेकिन फीड फॉरवर्ड में पहले हमें डिस्टरबेंस का पता चल जाता है तो आउटपुट में चेंज नहीं आता, मतलब नुकसान नहीं आता शुरू में।
Okay, so your answer is, अगर आप statement में कहें so that I can write it here, the answer is, if you can, अगर आप मुझे बताएं तो मैं कुछ statement लिख दूं यहाँ पे। शाबाश। in feed forward identifies the disturbance. So we have two answers coming to here. Let me complete with the one answer here. और जिसका जो आंसर है वो काइंडली अपना आंसर जो है वो मुझे बताएं so that I can add it here. So one answer I have here from Hamda, right?
Yes, sir.
Okay, Hamda says कि इसका आंसर क्या है? In feedback control, the disturbance has affected, let's say, the output Y, and then this effect on Y is reflected in the feedback error E. For example, this was the Y offset point, or plus, and then we have a feedback signal from Y measurement, और फिर ये एरर होता है जो कि आपके पास कंट्रोलर, फीडबैक कंट्रोलर के पास आएगा। फीडबैक कंट्रोलर, so and then it goes right. So इसका मतलब है कि in feedback the action is taken, so the action is taken after the system is disturbed, is being disturbed, okay, whatever. Or while in feed forward, action can be, is taken as soon as the disturbance is changed, disturbance occurs, okay. Okay, anything you want to add to this statement? Disturbance occurs. Okay, we have another answer. Okay, from Hasib. Okay, so I will take this one. Can we say in the feed forward the disturbance is isolated from the process? Not exactly. I will come to this. Let me check the answer from here. So we have one answer here. आप लोगों को chat नजर आ रही है अभी? Is it visible to you, chat? Steve says the feed forward identifies the disturbance and change the response accordingly. Therefore, the output is not affected by disturbance as it is eliminated earlier by the controller. Okay, very good. So I will take a snap of this as it is and put it there. Okay. Keep this. Okay, it's better कि आप लोग मेरे साथ notes बनाएं. This is very good. Okay, online में interaction is not easy, but I recommend highly. So now we have a question here. So the question is a quick question from Naba. The question says here, so can we have अच्छा ये अब जब मैं लिख रहा हूँ इसकी वजह ये है कि I will be giving you the class participation marks. So asking one question will bring you marks for sure. ठीक है आप लोग का. So the Naba asked about, can we say in the feed forward the disturbance is isolated from the process? Anyone want to answer this question? Actually, answer is we don't isolate anything. Okay, so we actually don't isolate any disturbances in feed forward. So let's make it a short form of FF, feed forward. Rather, we must measure, और अगर आप measure नहीं कर सकते तो what is other thing we need to estimate. So we need to estimate it or measure the disturbance. And we need to feed this disturbance directly to the controller, feed forward controller. The benefit is so this way controller can take a action, appropriate action, of course, action. इसकी ट्यूनिंग वगैरह हम देखेंगे, but the concept is so important कि the rest depends upon the equations and the modeling, the same thing that you have done before. So पहले concept बहुत ज़्यादा important है. Once you are done with that, तो dealing with the equation and block diagram is no problem. So this way controller can take appropriate action before the disturbance actually disturbs the process or plan. ठीक है, process or the plan. आप ये भी कह सकते हैं कि ये a sort of predictive, a sort of, we can say it is a sort of so feed forward is a sort of predictive controller. ठीक है, good. So nice, that's good. Okay, so with all these basics, this is nice. You're getting good understanding. I'm happy. Continue with this basic theme. और अब हम देखते हैं कि boilers के अंदर हमारे पास जो है what is the combination we have. This is a feedback control mechanism. Feedback control में we are taking the height or the height of the water, or which is basically the level height of water, or this goes back to controller, or controller जो है it is taking appropriate control action and manipulating the feed water. अच्छा, इसमें अगर इस steam is basically maybe कि हम बात जो कर रहे हैं ये हो सकता है कि ये किसी power generation unit की बात हो. It may be a power generation unit or whatever or some other, जिसमें ये steam जो है, steam is basically the output of the system. ठीक है. अच्छा, system means the boiler system. This steam is very important. It may be connected to some kind of a shaft. Prime mover के साथ हो सकता है कि this is connected with a steam engine, for example. Shaft of steam engine इसको लिखते हैं. Steam engine है कोई. तो steam engine में this goes like the input to the steam engine. और वहाँ पे further shaft के साथ आपके पास हो सकता है कि कुछ motors connected हों या load connected हों. So the load, as the load increases, ठीक है, demand अगर increase होगी, load demand increases, demand कह लें इसको या load कह लें, as this load or demand increases, the requirement of the steam will increase. इसकी increase होने की वजह से the dynamics will be changed here. So load, so this becomes like what I want to write here is कि for our feedback system, this steam is like a disturbance. ठीक है? So this steam for my feedback or for my control system, this is a disturbance. और ये disturbance जो है, it is basically maybe feeding some steam engine, or steam engine is further connected with some load. As the load increases, the steam demand is also increased. और हम ये कह सकते हैं कि आपके पास disturbance जो है ना वो बढ़ जाएगी. So now see कि अगर हम feed forward control use करना चाहें, तो in that case, in feed forward control, what we will be doing is कि हम इस disturbance को measure करेंगे. ये सिर्फ feed forward है, तो we are measuring the disturbance. और ये disturbance आप feed forward control को FFC feed forward control को हम provide कर रहे हैं. Feed forward control is manipulating the feed forward. अच्छा, this is only the case with the feed forward control alone. इसमें कुछ, there is no feedback. There is no feedback here. Only the feed forward control. Okay, ठीक है, ये category समझ में आ गई. Previously, there is no feed forward. We only have the feedback control. ठीक है. Next, we have both of them. So we have the feed forward and we have the feedback in this diagram. वो क्या रहा है, हम अपने सिस्टम की आउटपुट को भी मेजर कर रहे हैं और हम अपने सिस्टम की जो डिस्टर्बेंस है हम उसको भी मेजर कर रहे हैं. So we are measuring the output from our this is basically, I was writing meter, I think, yeah. So the level is also being measured. तो अब हमारे पास आपके पास जो है वो दो फीडबैक और फीड फॉरवर्ड दोनों आ चुके हैं. ठीक है, यहाँ तक बात क्लियर है आप लोगों को? Now implementing this thing, यहाँ पे तो हमने दोनों को simply sum कर दिया है, but after some time you will figure out कि ये इस तरह से बनी. And we have to add some algorithm here to have a balance between disturbance in the level, sorry, not disturbance, disturbance को नहीं यूज करते हम लफ्ज, इसकी बजाय हम यूज करते हैं between the change in level and change in disturbance. Okay, taking the level as a noun, disturbance as a noun, and the dynamics. So if there is some kind of a delta level, and if there is some kind of a delta D, तो फिर ये algorithm हमारा appropriately किसी equation के साथ उनको link करेगा. And the other thing that we need is the dynamics of the system itself. If you remember, हमने इस boiler को या इस तरह के system को okay, I'm not trying to go into the details of the mathematical modeling, but अगर आपके पास ये सब variables हों तो आप इसका model, boiler का model कैसे find out कर सकते हैं? Can anybody tell me how red color is good for a question? So at this stage, मुझे इनकी dynamic interaction पता करनी है. So there is a question right now कि how to get a simple working model of boiler here, so that I can use it in my control techniques. G, anyone can help me? We have studied. Of course, using data, right? Data किस तरह से हम कर सकते हैं? Can anybody recall हमने जो discuss किया है? What we can do is remove it. The first step will be put the system in manual. Put the system in manual. Manual means no controller, no feedback or feed forward controller. Just open loop controller. Just open loop controller. Open loop controller का क्या मतलब है कि ये कोई automatic signal नहीं आएगा, right? Rather, we will have something very interesting. और हम यहाँ पर इस system को, I have one answer here. Is step test. Very good. Very good. Hasib says step test. और हम यहाँ पर इसको अप्लाई करेंगे एक अदद स्टेप. अच्छा, ये स्टेप हम appropriately लेंगे कि practically हमें किस तरह से करना है. So we have one step test. What else? And we record the output. T and Y. Second, conduct. Okay, nice. Very good. We conduct the step test and collect data. Okay, so we will have one step input U, and we will have some kind of a output signal like this, Y of t. Next, we assume according to the output, select first or second order models. To keep things simple, we assume the first order plus that time model, which says the output by input is equals to some in k1 plus tau s e to the power minus theta s, and identify. And you did a very good solution of it in the last, I think that was the assignment, right? Now, if the dead time, अब यहाँ पे बड़ा interesting है, our feedback system may work. यहाँ पे अब हम, अच्छा, this is the third thing, and then we will have a model of this thing, right? Disturbance, of course, it is not in our hands. So some main points to make. So if theta is large, इसका क्या मतलब है? We have high dead time, large dead time. So in large dead time, feedback is not good and feed forward is good. इसके हम simulations के through check करेंगे, ठीक है? So by this, I took the opportunity to discuss this this simple issue of feed forward and feedback. कि एक तो वो opportunity है कि किस वक्त आप how do you decide किस वक्त आप feed forward use करें या feedback use करें. एक तो वो issue है कि जब आप system को identify करें and you figure out a large dead time. अगर large dead time है, in that case you must think about a feed forward control. We will do it in simulation as well. ठीक है, इसको हम simulation के साथ भी करके देखेंगे. But are you getting my point here? Okay. So keep in mind here. So the feedback control, इसके advantages क्या हैं? Let's discuss them one by one. एक ये है कि corrective action occurs regardless of the source and type of disturbance. क्योंकि feedback में हम we are concerned about we see only we focus on Y output only, and there can be many reasons that Y changes. ठीक है, for example, क्या वजह हो सकती है? It may be a noise, it may be a disturbance, it may be some change in the system. Okay, within the system अगर कोई चीज change हो जाती है तो time varying system, little bit of time variation in system components. Okay, और क्या हो सकता है जिसकी वजह से आप Y output change हो? Anything that is coming into the equation of Y. For example, when we say in state space, we say Y is equals to Cx plus du. So this means that anything, so Y can be changed because of any state variation or from any input or disturbance. So ये benefit है कि आपको अगर यहाँ पे there are so many things to care about, तो उसको हम ignore करते हैं and we try to make the focus only on the Y. Requires little knowledge about the process. So a process model, if it is not very good, तो feedback में हमने देखा था कि this can be, अच्छा feed forward में हमें मॉडल की जरूरत पड़ेगी, ठीक है। फीडबैक में हम एक अप्रोक्सीमेटेड मॉडल से काम चला सकते हैं। थर्ड इज वर्सटाइल एंड रोबस्ट, सो कंडीशन चेंज और वट एवर, अगर टोटली बहुत ज्यादा चीजें चेंज हो जाएंगी तो ओनली थिंग इज वी नीड टू रीट्यून द कंट्रोल। Disadvantages, you tell me about the disadvantage number one, feedback control, no corrective action until there is some change in y. So अगर इंटरनली कोई चीज चेंज हो रही है और y में नहीं आ रही तो फीडबैक कंट्रोल कुछ भी नहीं करेगा, ठीक है। If there is a state, for example, let's say there is some kind of a state x1 and x1 is varying, लेकिन there is no connection of x1 with there is no connection of f1, no change. Okay, y does not depend upon x1. Y, if does not um, uh, does not does not have any effect because of x1. So x1 कितना भी होता जाएगा हम कोई करेक्टिव एक्शन नहीं ले रहे। So this reflects कि आपका जो मॉडल है, मॉडल should be appropriate, मॉडल वीक नहीं है। खैर, I don't want to go into that detail. Disadvantages, feedback control is incapable of correcting a deviation from a set point at the time of its detection. Of course, it will take some time. Or theoretically not capable of achieving a perfect control, for sure, क्योंकि always you are looking for y, so there has to be a disturbance in y. This disturbance will reach to the controller और फिर controller को action देगा। तो हमेशा disturbance हमेशा variation होगी, इस variation को controller देखेगा and then controller action आएगा, ठीक है। Without any change controller will not do anything. So theoretically कहते हैं कि आपके पास perfect control नहीं, perfect control का मतलब है कि कुछ भी होता रहे, चीजें अपनी जगह पर ही रही। For frequent and severe disturbances, process may not settle out. और अगर चीजें बहुत तेजी से चेंज हो रही हैं तो वो कभी भी जो फीडबैक कंट्रोल है वो आपका सिस्टम को स्टेबल नहीं कर सकेगा, ठीक है। डिस्टर्बेंस इज गोइंग लाइक दिस एंड योर कंट्रोलर इज टेकिंग, फॉर एग्जांपल दिस डिस्टर्बेंस की वजह से कंट्रोलर जो है एक्शन लेगा थोड़ी देर के बाद, और वो एक्शन ले रहा है, अभी उसने एक्शन लिया है फिर चेंज होने लग गया, तो कंट्रोलर भी आपके पास जो है ना वो इस तरह से चेंज होता रहेगा। So settling time ही आपका नहीं होता। So disturbance is very dynamic and controller is also just following. ऐसा लगेगा कि जैसे controller is following the disturbance dynamics. या तो आपको फिर कंट्रोलर को बहुत फास्ट करना पड़ेगा, ठीक है। So this is the last point कि बहुत ज्यादा frequent as compared to the controller action और severe disturbances, इनके केसेस में प्रोसेस जो है वो आपका सेटल नहीं होगा, ठीक है। So this was simple logic. Feed forward control के advantages क्या हैं? So feedback control के benefits और disadvantages feedback के, इसमें किसी किस्म की कोई चीज जो अभी ना समझ में आई हो, kindly let me know. Feedback control you are studying since you have started your let's say control systems, first time you studied about it, और अभी भी and it will carry on. लेकिन हमें समझना चाहिए कि feedback is not the answer to all the problems, or it is not like magical stick. आपको properly उसको design करना होता है, and there is a limit जिसमें feedback control properly beneficial है, ठीक है। So there is an always a check on कि जब कब तक आपके पास feedback control जो है वो आपको benefit देगा, and the disadvantages are more than its disadvantages, ठीक है। Next class में हम continue करेंगे with the advantages of the feed forward control, and then we will see the feed forward and feedback control. Okay, and we will see some examples about it. Feedback control कैसा है, feed forward control में क्या, जैसे heat exchanger है तो what will be the difference between these two, We will see the design procedure for the feed forward control. Okay, how we make the equations take us to the control equation like this one. Okay, and this is a combination of the heat exchanger, right? So the what are the hardware requires? Then there is an example of distillation column. Okay, this we have example, and then we will arrive to this feedback and feed forward control, and how the equation, the design equation of this system. Okay, and then there is an example that we will do in the end. Okay, so see you in the next class. Thank you.